Joe is a left-handed guy. He writes with his left hand. One day, he decides to buy a study chair for himself and he orders online. And 3 days later, he gets this. Do you identify the problem? The problem is Joe is left-handed, but the chair is for someone who is right-handed. So, what Joe wanted was this kind of a chair. So, study chair like these are chiral objects. What do I mean by chiral? Let's go into it. An object is called chiral if its mirror image is non-superimposable on it. So to understand chirality, we need to understand what is the meaning of mirror image and what is the meaning of non-superimposability. And the word chiral is derived from the Greek word for hand, which is chir. Because our left hand and our right hand, as you can see, they are mirror images of each other, but they are not superimposable on each other. So there could be a little bit of confusion about superimposability of the left hand and the right hand. So to understand that, let's practice some examples and let's understand these two ideas, mirror images and superimposability. And then we can understand chiral objects much better. So two objects are called superimposable. If one can look exactly like the other. Okay, if one can look exactly like the other. For example, these two objects here, they actually don't look exactly like each other right now, but we can adjust these two objects. And let's try to adjust this one like this. So yeah, and now we see that they look exactly like each other, so they are superimposable. I think that should be clear. Let's take another example. How about these two objects? Now you can turn any one of these as you wish, but you would never be able to superimpose these two objects, right? So these two objects are non-superimposable. Let's take another example. How about these two? They look very similar, but can you superimpose them? So this is like in these positions, they are not superimposed. You can't call them superimposable yet, because this arrow is pointing towards right, but this arrow is pointing towards left, and you need to make one of the object look exactly like the other. So you might want to turn it around and adjust maybe, but if you turn it around like this and you adjust like say like this, now the arrow is pointing towards right, but they are not superimposable because this piece of wood is here. So any other way in which we can point the arrow towards right? Let's try maybe. If you do like this, then the arrow is pointing towards left once again, and it's of course not superimposed. How about in this position? In this position, if you turn it like this, then the arrow is pointing towards right, but then again it's not superimposed. So I don't think that they can be superimposed. So these two objects, they look very much like each other, but they are non-superimposable. Let's take another example. How about these two tables? So let's try and adjust them. Yes, they are superimposable. Okay, now let's see what do I mean by mirror images. The two objects are called mirror images if they can be adjusted in such a way that one can look like the mirror image of the other. So one can look like the mirror image. One is not the mirror image, because mirror image is something which is virtual, as we all know, but this is not a physical phenomenon. This is a logical relation. So let's try to adjust these two. we have already seen that they are superimposable, but are they mirror images of each other? Yeah, so in this orientation, you can see that yes, they are mirror images of each other. You can imagine a mirror in between them, and one of the object is like the mirror image of the other. How about this? So, are these two objects mirror images of each other? No, of course, no. How about this? They were non-superimposable, and are they mirror images of each other? Yes, they are, right? So you can imagine a mirror in between them, and one of the object is like the mirror image of the other. Okay, how about these? Well, we have seen this example before. They were superimposable, but are they mirror images? So to make the object, this object mirror image, I need to have the drawers on the left hand side, right? Because these drawers are on right hand side, I need to have the drawers on the left hand side. And if I do it, then the back side of the desk is pointing towards us. And what if I flip it around? Then again we see that the drawers are towards the left, but the top of the desk, you see, it's in the bottom, and you can't adjust them in a way that they are mirror images of each other. Okay, so as now we understand what do I mean by mirror images and what do I mean by superimposability, now we can understand chirality. But let's sum it up what we understood. So these two objects, they are superimposable, and they are mirror images of each other also. These two objects, they are non-superimposable, and also they are non-mirror images of each other. Well, these two objects are interesting. They are non-superimposable, but they are mirror images of each other. And this is what these kind of objects are called chiral, as we saw in the definition. But I am trying to point out something very interesting here. Like, you can also have the fourth class in which you have superimposable objects, but which are non-mirror images of each other. So don't let your mind make any kind of rule which is not there. Like, if two objects are superimposable, then they will be mirror images of each other or something like that, because we see that we have objects in all the possible four classes here. Okay, so once again, an object is called chiral if its mirror image is non-superimposable on it. And as we have seen, these two hands, so now in this position, now you can see that they are non-superimposable. I will try to superimpose one of the hand on the other, but you see, like, right now in this orientation you can see that they are mirror images of each other. But now if you want to bring the thumb on the left side, then you can't superimpose these two hands. And even if you flip it around, then of course you can't superimpose these two hands. So our hands are chiral, and that's where the word chiral comes from. Okay, let's try these examples. What do you think about this object? Is this chiral? So we will have to imagine its mirror image, and so suppose I make a copy of it like this, and in this software I can make the mirror image just by doing this. And you know, these two objects, as we have seen before, they are superimposable and they are mirror images of each other, but we want something which is non-superimposable on its mirror image. So is this object chiral? So the answer is of course no. How about this one? And here, so I'll duplicate it and make its mirror image. And then you have seen it before that they can be made mirror images of each other. They are mirror images of each other, right? Once there is a relationship of mirror image between two objects, it exists in all the possible orientation. Like if even if you flip that object around, that object is still the mirror image of the other one. That is very interesting, because once you have adjusted and you know, like, this signboard is the mirror image of the other, and now if you like flip it around, then it's still the mirror image of the other, but it has been rotated, right? So this is mirror image of each other, and you can try to superimpose them. They will not get superimposed, and this is an example of a chiral object, right? And then how about this chair? So this chair, can you identify? Let's look at it. It has nothing in it which can differentiate its left side with its right side, you know, and that's why I can say that it is not chiral. But to prove it, I will copy it, and I will take its mirror image, and I will superimpose it like this. So because it is superimposable, it cannot be chiral. For chirality, we need non-superimposability and mirror image relationship. So this is not chiral. Okay, so the last one is for the viewers to decide whether this desk, as you see, is this desk chiral or not. Thank you for watching.